So we're going to simplify some more radical stuff using a lot of the skills we've been working with these. So you guys tell me, square root of 3 times square root of 8. Either one of those, can you do anything with it?
It would be 4 on 2.
4 on 2 you could do for square root of 8. Great. So that's one way to do this kind of a problem, is to start out by saying for the individual pieces, can you simplify either one of them? So the square root of 4 is 2, so we get a 2 that pops out, and then we have a square root of 3 and a square root of 2 left, right? You can write them in any order. Remember, multiplication commutes. It's commutative. You can switch order of stuff, right? That's not the simplest way to write this, though. You definitely want to put those two roots together. I think with division and multiplication, we've been implicitly using rules. I'm going to have you discover those rules and write them down formally next year. That say, whether you've got two pieces multiplied or divided separately, or under one big root, is the same thing. So I can put these under one big root and say 3 times 2 is 6. And then you got to think, okay, 6, is there anything I can take out of that?
3 2.
Right, but like nothing that's a square number, right? Nothing that's actually going to come outside of the square root. So that's done. Another way to have done the same problem would have been to say, okay, do that part right away and say, what's the square root of 24? Square root of 24, let's think about this one in our head if we can. Square root of 24 has 4 go into it. How many times?
6.
And the square root of 4 is, with the 6 left over. That's probably a better way to do this problem, honestly, on this time. But you got to be flexible. You got to be able to do it both ways. Does that make sense, Mr. Gibson? Okay, so what do you guys think about the next one? If we've got 5 root 5 to the 4th power, do you want to write it out, 5 root 5 4 times? We could. I don't want to. Thinking you probably don't want to either. We could distribute. There's no minus or plus in here. Like down here you can't distribute because there's a minus. There's a separator in there. It's like a linebacker, right? Here you can just distribute the power. So I think this column is saying go 5 to the 4th and then root 5 to the 4th. 5 to the 4th you might not know. Something we're going to need to memorize soon though, to make algebra easier. Count it. 5 times 5? 25. Times 5? 125. It's like 5 quarters, right? $1.25. 125 times 5, that takes a little more effort. 125 times 5 is the same as 5 times 100 is 500. And 5 quarters is?
625.
It's 625. You got it. Very nice. That's actually a really nice number to remember, powers of 4. Next year we're going to remember powers of 2, 4, 3, a whole bunch. So I'm starting you with that now, so you have an advantage. How do you do the square root of 5 to the 4th power, though? Well, what's the square root of 5 squared only? They cancel, right? And you get 5. So the square root of 5 to the 4th power is that same thing twice. In other words, you can think about it like this. You don't have to write it, but you could think about it like this, right? Power to power is multiply. And the square root of 5 squared is 5. And then you've got this other squared, and 5 squared is 25. And then we're definitely probably want to go to our calculator here, not something we need to try to do without it. But really, this is 5 squared, this is 5 to the 4th. The answer is 5 to the 6th power here, if you know. So if you were to write 5 to the 6th power, you know, I'd be just as happy, if not happier, than the calculator answer, which is going to be what? 625 times 25 is... Okay. Yeah, we don't need to know that one at all. Too big. Okay. So what do you guys think on the next one? What should I do to simplify that? Well, you could, if these were like terms. Yeah, you're totally right, Miss Newitt. So definitely a good idea to pursue PEMDAS. But they're not, right? These are root 5s. That's the simplest they get, prime number. These are root 3s, prime number. They can't simplify. They're not the same thing. It's watermelons and apples here. But I could do this, bless you. Could distribute, right? Like, so I'd get the square root of 35 if I absorb those under one radical. And the square root minus the square root of 21. And then you want to think, okay, can I simplify either one of those? Maybe you can, maybe you can't. Any of our square numbers go into 21? Right amount here again, 4, 9, 16, I don't think so. Any of them go into 35?
It'd be about 4.4 or 5.
I don't think so. So I think this is done at that point, yeah? So that's kind of boring. But when you distribute on a problem like this, I know you guys are going to have problems in your assignment where these answers will break down. So be watching for that, okay? So what should I do on this one then?
Distribute.
Yeah, distribute. Everything to everything, right? So I'm going to distribute root 3 to both of these. So if I put that times that, I'll get root 9, right? And then this times this will be 2 roots of 3. This times this will be minus 4 roots of 3. This times this will be minus 6. This is just re-emphasizing skills you've already built this year, but now we're doing them with radicals. Those same skills that you've built this year with like parabolas apply to all kinds of other things, so you got to be fluent in them. Yeah, what's up, Miss Newman?
Root 3 times itself twice would be root 3 squared. There's 3.
Yeah, totally. Yeah, there's different ways.
Right,
There's different ways. If you want to write 3, I love it. That's great. I thought it made sense from what I said a second ago to do it like this. Miss Newitt's saying, hey, when you do this, these ones, root 3 times root 3 is the square root of 3 squared, and square root and squared, they cancel each other out. A very good way to think about it. You can also do it this way. Doing both is kind of important actually on this one. So nice comment. I love it. Any like terms in there?
2 and 4.
Yeah, these are the same. 2 minus 4 is
Negative 2.
-2. We've got an elephant in the background. Any other like terms? 3 and 6. It's minus 3. Can I put those together?
No.
No way. Totally different things. This is it. If you think about this, I don't know if we did the quadratic formula enough yet, but when you can't factor something and the quadratic formula doesn't come out nice, this is how your answers looked to the quadratic formula sometimes. So there's something to that with radicals and the quadratic formula. So maybe we'll do that next week. All right, so how about this one then? Can I do this? Yeah, the minus separator says you can't distribute. This in Algebra 2, by the time you get to Algebra 2, or you, God forbid, take the lowest college class called college algebra, this is like sacrilege, almost. If I see this on papers in my advanced classes, I almost have a heart attack every time when people do this. I'm like, oh my God, I've taught them nothing, I'm a failure! It freaks me out, okay? So that is dangerous right there. You've got to realize this is a linebacker blocking you up. What do you have to do to do this the right way? There's lots of ways to do this the right way. So the right answer is going to involve these, but something is really missing, and also that's not a minus. Very bad. Squared means twice. I believe I taught you guys 2 other ways to do this year too. There was a shortcut formula where you do the first thing squared, the last thing squared, and twice the things multiplied together. There was also Pascal's triangle, which we'll do again next year because I don't expect you to know it yet. But somehow you should look at this and be like, I can't just square both things. something else going on. If you're at that point, you're doing pretty good right now. You know what I'm saying? Something else is there, okay? So yeah, we're going to get 6 squared. Yeah, we're going to get this times this, but minus times minus is plus. That was one terrible mistake I just made. And then, well, we've got Lindsay's root 3 and root 3 again. What's that going to be? It's going to be root 3 squared, which is?
3. Plus like a 9.
Because it's not 3 squared, it's
Yeah.
root 3 squared, right? Or you could just say the square root of 9 if you liked that way better, Kate. Cool? But then we've got other stuff. That's the key. The most important part is there's other stuff. I only did those ones. I've also got this one and this one, right? So this times this is minus 42 of the root 3's. And this one is another minus 42 of the root 3's. Hence the shortcut formula, 2 of those. If you remember the shortcut formula, I'm jamming it up. Let me spread this out a little bit. So that was 49 times 3, right? So then what do we have like term-wise? 49 times 3, we might need to grab our calculator. It's like 50 times 3 minus 3, though. It's 150 minus 3.
147.
147. These are like terms, right? There's 2 42s, that's 84. Minus 84 of the root 3's. And then 147 plus 36, oh man. 177. Could go to your calculator.
183.
Yeah.
Oh, you got it.
Don't trust me. If you guys think I'm good at that kind of math, not true. Ask my calculus class. Okay. Numbers get me confused sometimes. Okay. So there's some basic simplifying stuff. I also wanted to review just a couple of problems from yesterday. Okay, so you guys from yesterday, can you help me? How do I do this first one? Because you can't simplify root 11 or root 3, right? Those are like done. What's the only problem? Yeah, you have to rationalize it by getting rid of any roots on the bottom. So how could you get rid of that square root of 3 on the bottom? It's like there, right? Like how do you do something with it? You're saying like multiply it?
Well, like, yeah, because if it's on the bottom, it's like...
Usually stuff that's on the bottom, we'd like to move it to the top by multiplying it. That's a great idea. But this isn't an equation. See? That's close though.
Don't you divide the 6?
Square. It's the same.
But you can't square everything because it's not an equation. You square one side, you gotta square the other side. There is no other side.
So
You've got to use a clever one.
It's all one side.
If you want to get rid of square root of 3, like Lindsay was doing a second ago, you want another square root of 3 there because that's going to make it 3.
Oh, okay.
But you can't just put blue stuff randomly there like that unless you do it to the top. This is not the same concept. In algebra, whatever level of algebra you're at, algebra 1, algebra 2, college algebra, advanced algebra, whatever, there are 3 main manipulation concepts. Do stuff to one side of an equation, you do it to the other side. That's one concept. This is not that concept. You can multiply stuff by a clever form of 1, any form you want, for all kinds of different purposes, and it doesn't change what it is. You don't have to have an equation for that. You can do it to anything. And there's the sneakiest one, which I don't think we've ever done yet. We'll start doing a couple times next year. We'll use lots of clever ones next year. Is you can add 0 to anything, can't you? You can add 0 to anything, but 0 comes in lots of forms, like 2 minus 2 is 0. So you can add 2 minus 2 to stuff. You're saying, why would I want to do that? It's just 0. There's reasons. You can add root 3 minus 3 to stuff too. That's just 0. Those are the 3 main concepts in algebra. Okay. This one's productive because we get what Lindsay had a second ago. Root 3 times root 3 is just 3. If you want to think about it as root 9 is 3, that's fine. If you want to think about it as root 3 squared cancels each other to get 3, fine. Either way. Up here then we're going to get the square root of what if we take them together? 33. So this is really root 33 over 18. Now, can you simplify root 33? No.
I thought you could multiply them
That's how you get rid of it.
if they weren't like terms.
You can't add or subtract stuff
Okay.
if they aren't like
Divide
terms.
and multiply.
Right. Multiplying and division kind of change what kind of things they are. It's like, what would you get if you multiplied watermelons by cantaloupes?
Get watermelon cantaloupes.
Yeah, exactly. You get something weird. Yeah, exactly. There you go. That changes their form, right? But if you just add, if you just say, hey, if you say, hey, I have 4 of them and I have 7 of them, you have 11 of them. Those are like terms. So those are the differences.
Tinkerman.
If you can figure out how to multiply them, I'll get on board. I don't know what would come out of it. Yeah. Okay. How about this one? Anything I can do? You guys should be able to tell me a few things.
Can open.
I hear 25. What's he mean 25? What? So I think he's splitting it up, in his head at least, thinking like this. And then he's saying, well, 125, 25 goes in how many times? 5 times.
5 times.
Remember, that's 5 cubed, really. Okay.
Did you do this problem as a cube equation?
Well, it's a square root, so we'll do some cube roots next week. But I hope before we quit for this year. So you can do this with all kinds of roots. There's no limit. There are cube roots, there are 5th roots, there are 113th roots. So same concept though. All right, so 5 square rooted is 25. Square rooted is 5. This thing square root's nice too. The quantity x minus 3 all squared square rooted cancels is x minus 3. Square root of y to the 4th. That cancels twice. Right? There's 2 y squareds in there, and they're totally gone. The only thing left over inside is that one. So that's good right there if you get to that spot. Pretty good. But it's not technically simplified because this is on the bottom. So you guys tell me, how do I make it go on the top?
You multiply both sides. I mean, you add square root 5 to the top.
Yeah, use a clever one. That's how you want to think about it. If you keep starting to think about clever one now, it's going to pay off. All right, so this is going to give us another 5. So that 5 times this 5 will be 25. We've got y squared still. And then I think we can need to distribute up here. So we'll have root 5x minus 3 root 5. And that's as simple as it gets. Now this versus that without the clever one, they don't look a lot simpler. This is just a process I'm teaching you. It's a reflex action. So one part of Algebra 1 is acquiring reflex actions. If you have them, stuff after it that's also, by the way, a lot more interesting will be so much simpler, and you won't have to think hard about it at all if you have those reflex actions. If you don't have them, it makes it harder.